Namaskar. Dear students, from the last video, there were 4 problems for homework, and you might have gone through those problems and you have solved them. Now you may confirm whether our solution is proper or not, and if there is any query, then you may contact me, and if there is a problem or if there is any mistake, then you may correct it. Now the first problem was related with the fundamental theorem for calculus. Second was related with the fundamental theorem for gradient. Next was related with the fundamental theorem for divergence. And the last was related with the fundamental theorem for curl. Now one by one we will discuss the solution of these problems. See, this is our first solution. Our function was f of x is equal to 3x square. It is only the function of x, and in the fundamental theorem for calculus we will have to prove that the integration from a to b derivative of f with respect to x dx is equal to f of b minus f of a, where a is 1 and b is 2. Our left hand side is this. First I have calculated the derivative of f with respect to x, it is 6x, and then I have integrated this with respect to x within the limit of 1 to 2, and the left hand side is 9, correct? You can go through this. Right hand side is f of b minus f of a, where b is 2, and see here it is b is 2 and a is 1, and therefore I will have to substitute. Wherever there is x, I will have to substitute 2. Wherever there is x, I will have to substitute 1, and then I will have to subtract them, and the value is 9, and therefore LHS is equal to RHS, and hence we can say that the integration from a to b of df by dx over x is equal to f of b minus f of e. It is fine. It is very simple. In 12th, you might have gone through this. Now we will go for the next proof. It is the fundamental theorem for gradient. For that, the scalar function given was 2x square y minus yz cube plus 3. The first point A, now it is in 3 dimension, therefore the point A with the coordinates 1 0 1, point B with coordinate 2 1 3. Now here I have considered 2 different points with totally different coordinates. The theorem says that line integration from a to b of gradient of f over dl, that is line, is equal to f of b minus f of a. And for that, first I have calculated the gradient of f, and this is the value of gradient. Now you are aware about how to find the gradient of a scalar function. Then I have started calculation of the line integral. Now see, actually we will have to integrate from 1 0 1 to 2 1 3. But if I observe the gradient, then in the gradient this term is includes only dx, that means there is no change in y. For the middle term there is dy, that means we will have to integrate over y and we will have to keep x and z constant. And for the third term we will have to integrate over z, and obviously at that time x and y will remain constant. And therefore instead of having the integration directly from 1 0 1 to 2 1 3, I have splitted it into 3 integrals. First integration will be from 1 0 1 to 2 0 1, that means only there is change in x, y and z remains constant, and I have integrated only for the first term because no need to integrate the second and third term. The dy is equal to 0, y remains 0 0, dz is equal to 0 because z remains 1 and 1. Therefore in this case, first term there is no need to consider remaining 2 terms. For the middle term, I have considered from 2 0 1 to 2 1 1. That means now x remains constant, there is change in y, z remains constant, and therefore no need to integrate the first and third term, only need to integrate the middle term where there is dy, that means only there is change in y. And then I have integrated from 2 1 1 to 2 1 3. That means finally it is the integration from 1 0 1 to 2 1 3, but with 3 different steps. First this 1012 201, then 2012 211, then 2112 213, and this is integration over dz. Now once we understand this, rest of the things are very simple. One more thing is this is important here, as there is a integration over x from 1 to 2, the value of y is equal to 0 and the value of z is equal to 1. You can observe 0 0 1 1, that means y and z remain constant. Here the value of x is equal to 2 and value of z is equal to 1, and in this case x is equal to 2 and y is equal to 1. Therefore I have substituted the value of x, y. Here y is 0 and therefore this is 0. I have substituted the value of x, z. Here x is equal to 2, therefore 2 2s are 4 into 2, it is 8, and then it is minus 1, therefore it is 7 dy. Initially I had made a mistake, I have written 3, but now actually it is 7. You can check, it is 2 2s are 4 into 2, that is 8, minus z is equal to 1, 1 raised to 3 is 1, and therefore 8 minus 1, it is 7. And same thing here, I have substituted the value of y to be equal to 1. There is no issue of value of x here, and z square remains as it is, and integration we will have to integrate 3z square. Now this is 0, therefore 0, integration 7 dy is 7y, upper limit, lower limit, it remains 7, and integration of 3z square is 3z cube divided by 3, and therefore it is z cube, upper limit is 3, lower limit is 1, and then the left hand side is equal to minus 19. Now when I think about the right hand side, the right hand side is a bit simple. For the right hand side, what I will have to do, I will have to find f of b, that means the point b has a coordinate of 2 1 3, minus f of a has a coordinate 1 0 1. If I substitute the values in the function and if I take subtraction, then again you will observe that the right hand side is minus 19. Therefore here also I can write left hand side LHS is equal to RHS. Our LHS was 1 minute. Our LHS was the line integration of gradient of f dot dl. Therefore this is same as the right hand side, it is f of b minus f of a, and hence we can say that the fundamental theorem for gradient is verified. Fine. Now what we will do, we will go for the next problem. The next problem was the verification of fundamental theorem for divergence. Correct? Here the function a bar, it is a vector function. A bar is equal to x square z I cap minus 2y j cap plus x cube k cap. The theorem says that it is volume integration of divergence of a over the volume, obviously it is volume integral, is equal to closed surface integration of a bar dot ds. This surface, closed surface, has to enclose the volume over which we are integrating. Okay. Now for that we have considered the rectangular box of length along x-axis, which is 3, breadth along y-axis, which is 2. Here it is x-axis, this is y-axis, and this is z-axis, and height along z-axis, it is also 2. Again I have started with the calculation of divergence of a bar. Therefore I have considered divergence of a bar. It is 2xz minus 2c. We are aware about finding divergence of such type of function, and therefore you can check the divergence of this is 2xz minus 2. Then if I consider the left hand side, it is the integration over the volume. Now remember that to consider or to cover the entire volume, what I will have to do, I will have to integrate over x from 0 to 3, then integrate over y from 0 to 2, and integrate over z from 0 to 2, because the height is 2 here. And therefore I will have to write it is divergence of a, it is 2xz minus 2, and integration. See, the convention is that if I write the volume element dx dy dz, then the integration over x is from 0 to 3, order should be maintained, y is from 0 to 2, and z is from 0 to 2. But while solving this, we will have to solve it one by one. Therefore if I consider the integration over z first, then I will have to write the limit 0 to 2, because integration is over z from 0 to 2. Then I will have to integrate over y, and for that limit is this, it is 0 to 2, because for y the limit is 0 to 2. And then I will have to integrate over x, and these are the limits for integration over x from 0 to 3. Now one by one if I solve this, it is 2xz minus 2. The integration will be x z square by 2, that 2 gets cancelled, minus 2z, we will have to substitute limit from 0 to 2, it becomes 4x minus 4. Then I will have to integrate over y. The integration will be 4xy minus 4y. I will have to substitute the limit over y from 0 to 2. Therefore, if I substitute y to be equal to 2, no need of substitution of 0, that will be 0. Then it will be 8x minus x. Then I will have to integrate over x from 0 to 3. And the integration will be 4x square minus 8x. If I substitute lower limit and upper limit, then that is equal to 8. Therefore, the left hand side of this fundamental theorem for divergence is 8. And now I will have to check for the right hand side. Now see, this is the right hand side of our fundamental theorem for divergence. It is closed surface integration of a bar dot ds bar. Now remember that if I calculate a bar dot ds bar, then the value of a bar dot ds bar, see, this is our function. Then value of a bar dot ds bar depends on the surface, and to cover all the surfaces, that means to have the closed surface, I will have to consider the front surface, back surface, right surface, left surface, top surface and bottom surface. See, here dy dz along x axis, see, this is dy dz, that means if I consider this surface, front surface, it is parallel to yz plane, and therefore the surface element will be dy dz, and it is assumed to be along x axis, therefore it is I cap, and hence it is x square z, see, it is x square z dy dz I cap dot I cap, that is equal to 1. But if I consider the back surface, this is the back surface, again it is in yz plane, see, back surface is also in yz plane, but as the front surface is assumed to be along positive x axis, the back surface is to be assumed along negative y axis, and therefore this is negative I cap, but I cap dot minus I cap will be minus 1, and therefore this is negative sign, it is x square z dy dz. Same situation is there. If I think about dx dz, if I consider the right surface, then the right surface is parallel to xz plane, and therefore element is dx dz. As it is to the right, it is plus j cap. But if I think about the dot product with a bar, it is minus 2y. Therefore, it is minus 2y dx dz j cap dot j cap. J cap dot j cap is equal to 1, and therefore it remains as it is. Whereas for the left surface, it is in xz plane, but it is along minus j axis, and therefore here I will have to write it is minus sign. Then it is integration 2y minus 2y dx dz. And same thing for the top surface. For the top surface, this top surface, the integration is or x y, therefore it is dx dy, and it is along z axis, therefore only the third term is to be considered, it is x square, correct. Same thing for the bottom surface is in xy plane, but it is along minus k cap, and therefore this is the negative sign. Another thing is that for this, if I consider the front surface, for the front surface, for any point on this surface, x is equal to 3, because the length along x axis is 3, and therefore here I have mentioned that for this integration, wherever there is x, I will have to substitute 3. But if I consider the back surface, for back surface it is in yz plane, and therefore I will have to write x to be equal to 0. For the right surface, this right surface, see, you will observe that for the right surface the value of y is equal to 2, therefore for this y is equal to 2, whereas for the left surface y is equal to 0. Obviously for the top surface, you will observe that this is top surface, z is equal to 2, here I have mentioned z is equal to 2, and for the bottom surface, which is in xy plane, z is equal to 0, correct. Now this step is important in this solution, because here we will have to consider the physics, we will have to cover all the surfaces, we will have to think about the directions for that surfaces, and then we will have to take the dot product with the a bar. And once we write this term, then rest of the things are very simple. Again, this integration is over two variables, y and z. I will have to substitute x to be equal to 3, therefore it will be 9z. When I integrate over y, I will have to change variable, I will have to integrate from 0 to 2. When I integrate over z, after that I will have to integrate from 0 to 2, and therefore this I will integrate 9z from 0 to 2 over y, and then the result will be integrated over z from 0 to 2. If I substitute x to be equal to 0, then this term will vanish, it is 0. Here if I substitute y to be equal to 2, then it becomes minus 4, and therefore it is minus 4. First I will have to integrate over z from 0 to 2, and then I will have to integrate over x from 0 to 3. In this case, if I substitute y to be equal to 0, then this term will vanish, and therefore here it is 0. Here I will have to substitute z to be equal to 2, but x cube does not consist of z, and therefore there is no need of substitution of that. I will have to integrate x cube over x from 0 to 3, and after that over y from 0 to 2, over y from 0 to 2. Same thing here, only there will be a negative sign. Now you will observe that this is 18z from 0 to 2 plus it is integration from 0 to 3. See, you will observe these two terms are same with opposite signs. This is plus and this minus, therefore these will cancel. And then I will have to consider this term only, it is 8. But why I have written it? I have directly solved this. The integration over z will be minus 4z, but if I substitute upper limit, then no need of substitution of lower limit, it will be 0. In I substitute upper limit, it will be 4 into 2, it will be 8, and therefore I will have to integrate 8 minus 8 with x. Same situation here, it is 9z square by 2, but if I substitute upper limit, then it will becomes 2 2s are 4 into 9 divided by 2, and it will be 18z. Okay, I will have to integrate over this. Here it is 9zy, and if I substitute y upper limit and lower limit, then it is 18, and 18z I will have to integrate over z, correct? And the answer of the right hand side is 8. And you will observe that the left hand side was 8, it was the volume integral, that is left hand side is the volume integral. See, this was the volume integral, left hand side was volume integral. We have already observed that this is equal to 8, and this is the right hand side, which is the closed surface integral, and that is equal to 8, and therefore I can write it is volume integration of divergence of a bar dv, it is volume integral, is equal to closed surface integration of a bar dot ds bar, and this is nothing but the fundamental theorem for divergence. Fine. As a last part, we can think about the last theorem, which is the fundamental theorem for curl. We have used the same function, it is x square z I cap minus 2y j cap plus x cube k cap. But for that, what I will have to do, or what we will have to consider, we will have to consider a surface which is bounded by the line, correct? And therefore in the problem we have considered the surface which is like this. It is bounded by 300, 350, 352 and 302. That is, it is parallel to yz plane and at x is equal to 3. Therefore, this is 300. See, to find the left hand side, first of all, I have calculated the curl of a bar, correct? This is curl of a bar. Again, we are aware about how to find the curl. Then this is the value of curl, it is minus 2x square j. Now you may think about, I have considered the function which is a bit simple, that is only one term is there for the curl and it is obvious. Now if you think about another function for the homework, then you may reach to several terms, but see, it may be complicated but it is not difficult. You will have to write patiently each and every term one by one, and then you will reach to the proper destination, correct? Then what is left hand side? Left hand side is the integration. See, you will observe that this surface is parallel to yz plane and therefore it is dy dz along x axis, and therefore I have considered it is see, if I take a dot product dy dz along x axis, that is I cap, and dot product with this curl of a, then curl of a is along j cap, and therefore it is 0 and it becomes 0. Now always it may not be 0. Sometimes suppose this consists of some additional term, say for example 3xyz I cap, then you will have to take a dot product of this, then it will be 3xyz dy dz, and you will have to integrate. But now you are aware about how to integrate over the surface, and therefore you can solve this problem. In this case, for our problem, it is 0. Fortunately, it is 0, and therefore it becomes simple for me. What is the right hand side? Right hand side is a closed line integral. See, it is closed line integral. Now, what is the importance of right hand rule? See here. Here, as we have considered the surface along x-axis, I have traced out the loop from 300 to 350. That means in anti-clockwise sense. Anti-clockwise sense. That is first y to z, because the direction is along x-axis. And therefore, the total line integral, I have split it into 4 parts, and I have written, see, it is closed line integral. I have split it from 0 to 5 along y-axis, from 0 to 5 along y-axis, and for that x is equal to 3, y is equal to 0. See, x is equal to 3 and y is equal to 0. Then from 0 to 2 along z-axis, right? Then from 0 to 2 along z-axis, and for that x is equal to 3, y is equal to 5. X is equal to 3, y is equal to 5. This is for entire plane. X is equal to 3. Only y remains constant for the vertical line. And same situation, then from 0 to 5 along y-axis, 0 to 5 along y-axis, where x remains constant and y also remains constant. Y remains 2, x remains 3. Z remains 2. And then integration is over z from 2 to 0. Z varies from 2 to 0. Z varies from 2 to 0, where x remains 3 and y remains 0. Where x remains 3 and y remains 0. Then I will have to substitute. Therefore, if I integrate this, it will be minus 2 y square by 2. 2 gets cancelled, and it is 25. If I substitute, then it is minus 25. Same situation here. I will have to substitute x to be equal to 3, y to be equal to 5, and I will have to integrate over z. You may integrate this. You will reach to 54. Here it is plus 25, and here it is minus 54. Again, the answer will be 0. And therefore, again you may write, it is LHS is equal to RHS, where LHS was the surface integration of curl of A dot ds, and RHS was closed line integration of A bar dot dl bar, where this line, closed line, has to enclose the surface over which we have integrated. And therefore, this is the proof for the fundamental theorem for curl. Finally, we have reached to the proofs for all the theorems: fundamental theorem for calculus, fundamental theorem for gradient, fundamental theorem for divergence, and fundamental theorem for curl. Now, as a homework, you may check for another function and another volumes or another surfaces. If you think about a rectangular box of any shape, then you will have to consider all the surfaces which bounds that volume. If you consider any surface, then you will have to consider all the line elements which bounds that particular surface. Try to solve such problems. Thank you.